Okay, today is 6.3 exponential functions. I want you to look at page 178 of your student journal. On page 178 of your student journal, I want you to complete exploration number 1 with your groupies. We're going to put in values for x here. All right, so I'm putting in 0. When I put in 0, what do I get out? 16. And some of you, it may help if you write. For some of you, may want just some room to write it out. So that's not a 2, that should be a 0 up there. Okay, you're putting that 0 in for that x right there. So that gives me 2 to the 0, which is 1 times 16, which is 16. And then 16 times 2 to the first. What's 2 to the first? 2 times 16, 32. And then 16 times 2 to the second. That's 4 times 16 is 64. And some of you may have noticed the pattern early on it. What's happening every time? Yeah, it's doubling every time. You're taking, notice here you have 2 to the 0. That means you just have 16 if I write that out in expanded form. Here you would have 16 times 2 to the first. Here you have 16 times 2 to the second, which means you multiply by another 2. Here you have 16 times 2 to the third, which means you multiply by another 2, one more 2. Here it's 16 times 2 to the fourth, so you multiply by another 2. Okay, so I'm just doubling it. Each time I'm multiplying by 2. So this one here is 256. I don't even have to do the math now. This one here, I know I'm going to have a fifth 2. I'm going to have that. So that's going to be 512. Okay, that's what an exponent does. Rather than adding, like on x we're adding by 1, but here we're multiplying. Okay, this right here, times 2, notice they're now going up by how much over here? By 2. And when you put these in, 16 to the 0 we already know. Or excuse me, 16 times 2 to the 0 is 16. And then we go down to here, this is 64. We now have to the fourth, which is 256. What's happening now? Yeah, you're multiplying by 4 now. Why? Because you skipped something in between. You're not going up by 1s. Okay? So this one would be 256 times 4. What do we get here? 1,024. And 4096. And then 16,384. So multiplying by 4 each time there. Because this isn't going up by 1, it's now going up by 2. All right. So remember, exponents give you repeated multiplication. Okay? So if you just look at this function right here, the one they're telling you to find the table for, what are you going to be going up by every time? On y. Okay, let's go back up here. What was our number that we were multiplying by? 2. The 2 was our base. What are we going to be multiplying by here? 1/2. That's our base, as long as you're going up by 1 over here. So here you're not going up by 1, you're going up by 2. So if you're going up by 2, you're going to have to multiply by, here we did 2 times 2, which is 4. Here we're going to do 1/2 times 1/2, which is 1/2 times 1/2. Those of us don't know how to multiply fractions. Multiply top by bottom, or tops and bottoms. 1/4. Okay, go ahead and fill out those 2 tables. Okay, so if we're evaluating this function for the given value of x, I have 16 times 1/2 to the 0 power. What do I get? 16. And then 16 times 1/2 to the first power is 8. Okay, we just multiply. Did anyone find any problems with their calculators as they were plugging this in? Any kind of issues they were having? No? You guys all put parentheses around the 1/2? Yeah. Anytime you have a fraction, put parentheses around it. That's a big deal. Even if there's a especially if there's a fraction in the exponent position. So the next one would be 2, and then 1, and then 1/2. Yeah. Okay. Each time we're multiplying by 1/2. I obviously stopped showing the work there because I can see the pattern happening. Okay. And we know that this one's 16. We know that 2 is 4. We know that 4 is 1. If we're multiplying by 1/4 every time, 6 is going to be 1/4. Okay? And then 1/16, and 1/64. All right. So hopefully we've done enough to be able to understand that statement. As the independent variable x changes by a constant, the dependent is multiplied by a constant. Okay, if it's going up by 1 for the independent, then the constant we're multiplying is called our base. It's that number that's being raised to a power. Okay? Any questions there? Why do we create tables? Yeah. Okay, it helps to see patterns. Helps to see what x and y equals. What else does it help us do? Logan? Makes it much easier to graph, which is kind of what we're doing next. Exploration 3, if you take a look at that. It says, work with a partner and sketch the graphs of the functions in exploration 1 and 2. Okay, now, please note, how many functions did they give you in exploration 1?
1, 2, 3, 4.
Okay, everyone on your fingers. How many functions did they give you in exploration 1? Up here. Okay, everyone's got a bow, man. Come on. Okay, tell your neighbor what the functions were that they gave you.
Is the function the tables or the equation? That's helpful.
Okay, someone volunteer, tell me the functions that they gave me in exploration 1. Kaylee? Good, they gave us that function. You filled out 2 different tables for that function. How many functions did they give you in exploration 2? 1. They gave you that function. You were graphing those 2 functions. Okay? I would suggest when I was doing that when I do that on exploration 3 here, that you just graph the first quadrant. I think you'll be okay with just the first quadrant there. Okay? So, figure out what your scale needs to be. You guys can work together on it. You go. I don't necessarily expect you to be done yet, but one of the problems becomes, what do you want your scale to be? What intervals do you want to go up by? So, on the x-axis, what should we go up by if we're using, say, this first table here? Yeah, probably 1s. 1, 2, 3, 4, 5, 6, 7, 8. Okay? You could either mark 8 there, or if you don't put anything, it's assume you're going up by 1s. Okay? What do you want to go up by? Should we go up by 1s on y? Probably not. If we're going up front, or if we're going to 16 to 512, right? What are we probably going to have to go up by? 16? Well, that would give me 16, 32, 48. Okay, we don't get too far, do we? Go up by 10s?
No, go up by 64.
64s? 32s?
How about just 50?
Hey, I'm fine. 64s or 32s? Okay. Does 32s get all these on there? Does 64 get all of them on there? 64, 128, What's the next one? Thank you, 192, and then 256. So it looks like we're getting closer. 320, 384, and 5. Whew, dude, that's a good one to go up on. There we go. So you have to go up by a constant amount. It doesn't have to be the same on each axis. Here we're going up by 1s, but it has to be constant. Okay, there, got it. Should we, could we put a 0, 0? If I put 0 in for x, do I get 0 out? No, should actually be 0, 16, but almost looks like 0, 0, right? Did I miss one? 32 should be right there. I think I missed the point there. There we go. All right. Okay, don't forget your arrows on the end. It continues to go. Okay, tell your neighbor what you're going to go up by on exploration number 2. Still going up by 1s on the y, or x, I mean? Yep. How about on the y? 2? 2, 4, 6, 8, 10, 12, 14, 16. Okay. All right. Cool. Very good. You got number 4 and 5. You can answer on your own there. All right. We will finish up with number 4. You can answer on your own. Number 5 we'll finish up tomorrow. Okay? Okay. We'll come back to this. It's going to be part of what we're doing tomorrow, but your assignment right now is to complete 1 through 9. 1 through 9 on page 181. Okay? And then number 10 and 11 on page 182. Okay? 1 through 9, page 181, and 10 and 11 on page 182. Okay? Please make sure to make a table of values on these. And I'd suggest making my table like this, so you have room to kind of keep track of some work. Okay, 10 and 11 will challenge you a bit more. 1 through 9 on page 181 and 10 and 11 on page 182. Okay, off you go.